Hello everyone, so today we are diving into adventure of determination of hybridization of an atom in a molecule or in an ion. So let us start it. Before starting the same, let us consider an atom AB4 or molecule AB4. In this AB4, AB central atom, always the central atom will be the one which has less number of atoms, less number of the similar atoms. B4 is terminal atom. B4b terminal atom. Terminal atom. So its structure will be like okay, A 1 2 3 4, here B and B means it has 4 sigma bonds. 1 2 3 and 4. It has 4 sigma bonds. If it forms 2 bonds on 1b, if B is oxygen, it happens. So if it forms 2 bonds on 1b, then there will be 1 sigma and 1 pi. If it forms 3 bonds, what happens if it forms 3 bonds? Here if there are 3 bonds, then there will be only 1 sigma and there are 2 pi bonds. This is the concept of sigma and pi bonds. Okay, so here after getting to know about sigma and pi, always the concept is that in any molecule always there will be number of sigma bonds. Number of sigma bonds is always equal to number of terminal atoms. So in AB4 we have 4 sigma bonds. If I take AB5, it has 5 sigma bonds. That is the concept of sigma. So that is the thing. So that was one of the pre-concept of determination of hybridization. Now lone pair. If I come to lone pair, okay, let me take an example of SO3, sulfur trioxide. Okay, SO3, let it be SO3. If I take an example of SO3, how many sigma bonds it has? Simply it has 3 sigma bonds. As you have learned the concept of sigma. Now how many lone pairs are there in this atom? If I take this atom or molecule, sulfur has 6 electrons. 6 electrons with it. Sulfur has 6 electrons. Okay, sulfur has 6 electrons with it. 6 electrons. And oxygen took 6 electrons because oxygen has valency 6. It want two electrons. Okay, so it took 6 electrons from, as there are 3 oxygens, as we have 3 oxygens, 3 into 2 which is equals to 6. It took 6 electrons. So the lone pair we have to subtract the number. It will be 0 if it comes 2. Otherwise let it be any molecule. If lone pair comes 2, sorry, if the answer comes 2 after this thing, what I wrote the number here upside, after the number is being subtracted, if the number comes 2, then it has 1 lone pair. If it comes 4, it has 2 lone pair. That is the concept of lone pair. So this was the basis of determination of hybridization. That was the basis of determination of hybridization. Okay, now if I move to the determination of hybridization, we will introduce a new concept of steric number. Some of the students may be knowing the steric number. What is the steric number? This number we will get by the addition of number of sigma bonds number of sigma bonds by the addition of number of sigma bonds and number of sigma bonds plus number of sigma bonds plus lone pair of electrons, number of sigma bonds plus lone pair, then I will get this steric number, then I will be getting this steric number. So what if the steric number is 2? What if the steric number is 7? What if this is 6? Let us see what will be the hybridization of an atom if 2, 3, 4, 5, 6, 7. Okay, what is the hybridization first? Okay, now let us see what is the hybridization if it is 2, 4, 6, whatever. Just we have to remember this table, then our work will be done of determining the hybridization. These concepts will help you in most of the chapters upcoming, in organic, inorganic, physical, whatever it be, it will help you. Hybridization is the basis of the whole JEE chemistry. Yes, so it is important to know how to determine the hybridization first. So we will study it. Okay, so here, yeah, what if the steric number is 2? That is, what is steric number? Number of sigma bonds plus lone pair. If it is 2, what happens? If it is 3, what happens? If it is 4, what happens? 5, what happens? 6, what happens? And 7, what happens? If it is 2, the hybridization is sp. If it is 2, the hybridization is sp. If it is 3, the hybridization is sp3. If it is 4, the hybridization is sp4. Sorry. If it is 3, the hybridization is sp2. If it is 4, the hybridization is sp3. If it is 5, the hybridization is sp3d. If it is 6, the hybridization is sp3d. D2 will come here. sp3d3 for 7. How to remember this? Sp is the base. We have to remember Sp. It is the base. Just to remember, we are considering it as a base. S will be always 1. S will be always 1. P will be maximum 3. S will be always 1. P ka maximum is 3 and D ka maximum is 3. It can move also. Okay. Now Sp for 2 it is Sp only. S1 P1. 3 S1 it is filled. P2 4 S1 P3. P3 is filled at 4. So at 5 if I move, it is Sp3. 3 is filled here, but I am taking D. One more is remaining. One more steric number is remaining. 6 Sp3D2. This is the way to remember this thing. This is the way to remember this thing. Right. Next comes, we will see some of the example based on the steric number. My God. Right. We'll keep it aside so it can help us while we were solving the problems. Right. So here, let us take an example of SO3 only, which we had took earlier. SO3 itself. Okay. SO3. In SO3 we have how many sigma bonds? We have to see the number of atoms in terminal atom. So we have 3 here. It means that we have 3 sigma bonds. 3 sigma. Next, what we have to do, what we have to see to find the steric number, that is number of lone pairs. In sulfur, we have 6 electrons. 1 2 3 4 5 6. In oxygen, okay, in oxygen we have 6 electrons. 1 2 3 4 5 6. 1 2 3 1 2 3 4 5 and 6. 1 2 3 4 5 and 6. So in sulfur it has expanded octet. It has expanded octet. It means that it can expand its number of valency out of it. It can reach 12 also. Okay, so due to that it forms a very good bonds with other atoms. So it wants 2 electron. It is needed for 2 electron. I will take 2 electron from here, and it also needs 2 electron. Let it be, we will think about it later. It also needs 2 electron. It also needs 2 electron. Okay, now the lone pairs are where? There are no lone pairs here. No lone pair. If I will erase this bond, if this O2 was not there, if this thing was not there, then I shall get one lone pair. Why? Here 2 atoms are 2 electrons are remaining. Then 2 electrons is equal to 1 lone pair. It will be 1 lone pair. But what I am having here is 3 oxygen. So it is also taking this. So the lone pairs are 0 here. So here, if I observe, the lone pairs are 0. Whenever the lone pair is 0, 0 will come here. Then the steric number here is what? The steric number is 3 itself. But for 3 we know that it is sp2 hybridized. Then our SO3 is sp2 hybridized. SO3 is sp2 hybridized. That was the concept, simple. Next we will see some more examples based on this thing. Okay, let me take an example of AlF4 minus. AlF4 minus. Now how to do this? See. Yes, right. Now aluminium has how many electrons? 3 valence electrons. 3. And here minus is there. Whenever there will be charge on a molecule, give it to central atom. If there is minus, there will be plus 1 electron. And fluorine ka valence is 7. If it is 7, then it will be needing, it will need 1 electron to complete its octet. Then there are 4 chlorines, then it will need 4 electrons, but minus 4 here. Okay, minus 4 will come here. Minus 4, if it comes 0. What is 0? Lone pairs is 0. The number of lone pairs remaining on the central atom is 0. Then how many sigma bonds are formed here? 4 sigma bonds, because the number of terminal atoms are 4. 4 sigma plus 0, which is equals to 4, which implies it is sp3 hybridized. If it is sp3 hybridized, let me see one more example so that the conceptual understanding will be there. Okay, so right, if I take OI2, don't want OI2, I will take NH3. If I take NH3, okay, NH3 we are taking here. If I am taking an example of NH3, so what is the thing here? Sigma bonds. How many sigma bonds? What is the sigma bond? The number of terminal atoms. Remember it, the number of terminal atoms is equal to sigma bond in any molecule. So it has 3 sigma bonds. 3 sigma bonds. Now the number of electrons with nitrogen is 5. The number of electrons with nitrogen is 5. Valence is 5, and it is giving 3 electrons. Hydrogen needs 1 electron. Okay, and we have 3 hydrogens into 1, which is equals to 3, so 5 minus 3, which will give me 2. If I have 2, it means that I have one lone pair, and totally I need, now what I need is plus 1, right, here comes plus 1, which is equals to 4. Again it is sp3 hybridized. So let us see some more examples. You can try them and the answers will be displayed. Right, so here we have some more examples based on the same. Try them and get the answers and match your answers. ClO3 minus will be sp3 hybridized. OCl2 is also sp3 hybridized. sp3 means its steric number is 4. And you can see it in our table here. Okay, yes. PCl5 is sp3d hybridized. ClF3 is also sp3 hybridized. That is the thing you can note here. You can match your answers. So if the content finds you helpful, please like, subscribe and comment. Thank you.